Hello viewers, so we have this question under chemical kinetics. It says the initial concentration of a reactant in a zero-order reaction is 0.75 molar. The rate constant is 0.015 molar per minute. The first question is saying what will be the new concentration of the reactant after 15 minutes? And you have the second one saying how long will it take for the concentration to be reduced to 0.06 molar. And then B is saying it took 143 seconds for 50% of a particular substance to decompose. If the initial concentration is 0.06 molar and the decomposition reaction follows second order kinetics, what is the value of the rate constant? So yeah, let's go ahead and solve the question. So what will be the new concentration of a reactant after 15 minutes? Now we are told to say this is following a zero order. So we can find the new concentration after 15 minutes by using the integrated rate law for a zero order reaction. It's given by the final concentration or concentration at a time is equal to minus kT added to the initial concentration like that. So this is the formula we need. And the concentration we are looking for is this concentration at a time, or the final concentration. We are given the rate constant K. We are also given time to be 15. We are also given the initial concentration. So all we have to do is just replace. So let's do that. This will be equal to minus our rate constant is 0.015, and this has the units of molar per minute, like that. And this is multiplying by time we are given, say, is 15 minutes. So we'll have our 15 minutes there. And then this must be added to the concentration that we are given initially is 0.75 molar concentration. What we have to do here is mathematics. 0.015 multiplied by 15. This is giving me a minus 0.225. So that's what I'm getting there. And then this is added to 0.75, like that. Now remember, here our units are going to cancel. This minute and that minute will cancel. Our final concentration will be in the units of molar concentration. So when you say minus 0.225 plus 0.75, what we are getting is our final answer is 0.525. And this is in the units of molar concentration. So that's our answer for the first part. So after 15 minutes, our concentration will change to 0.525 molar. That's it for that one. Let's go to the next one. So the next one is saying, how long will it take for the concentration to be reduced to 0.06 molar concentration? All right, so still from the integrated rate law equation for a zero order, if we make T the subject of the formula, we'll find out that our T from the same one, which is A, the final concentration is equal to minus KT added to the initial concentration or concentration at the beginning. If we make our T the subject here to find the time, we'll find that our equation will be equal to T is equal to, we'll have the initial concentration there being subtracted by the final concentration, like that. Then this will be divided by the rate constant K. So that's what we are going to have. Replacing in there, Our initial concentration is still 0.75, like that. And then this is subtracted by, they are saying it will reduce to 0.06. So that's our final concentration. And this will be divided by the rate constant. We still have 0.015. So all we have to do is do mathematics there. And this, when we say 0.75 minus 0.06, this is giving me a 0.69. And then down here, we still have a 0.015. And when we divide again, according to my calculator here, our final answer would be 46 minutes. So it implies to say it will take 46 minutes for our concentration to change to 0.06, like that. So that's our answer for part 2. Yes, so let's look at the last one, which is part B in this case. Here we are saying it took 143 seconds for 50% of a particular substance to decompose. Now, whenever we hear 50% of a substance, time taken for 50% of a substance to be used or to decompose or to finish up, that implies to say we are given half-life. So our half-life here is given to be 143, and the initial concentration is given to be 0.06 molar concentration. So they are telling us to say we need to find the value of the rate constant. We can find that by using the half-life equation for a second order, since they are telling us to say it follows a second order kinetics. So half-life for second order is given as T half is equal to 1 divided by K, that is multiplying by the initial concentration of the substance, like that. So in this case, making K the subject of the formula, you find that our K will be equal to still 1, that is being divided by the half-life, which is T half, multiplying by the initial concentration, like that. So this is the formula we use to find our K value. Replacing there, we find that our K is equal to 1. Our T half is given to be 143, like that. And then this is multiplying by the initial concentration is given to be 0.06. And our rate constant K will be equal to, what we'll have here is, we'll have that 1 on top there, but this is dividing by 143 multiplied by 0.06. This is giving us 8.58. And when we do our mathematics there, 1 divided by 8.58, this is giving me 0.1166. And this will have the units of m to minus 1, s to minus 1, which are the units for a second order reaction. So 0.1166 per molar per second is what we have as the value of our rate constant, like that. So this is how we go about this type of questions. We just need to understand the information we are given and how to interpret it. If you found this to be useful, if you found it to be helpful, subscribe to our channel, share, like, and comment so that we can make more videos like these ones.